All right, hi everyone. Welcome to STG338. My name is Alex Martineau, and I'm the General Manager for Elastic File System here at AWS. I'm joined for this session with Perry Jeanette. Perry's a Senior Solutions Architect for file storage here at AWS. And we're also joined with a special guest, Dave Smith, the AWS Lead Architect at SAP Enterprise Cloud Services. You'll be hearing from Dave and Perry just a bit later in our talk. Before we get started, I just want to thank everyone for joining our session today. It is my privilege to have you here to learn more about storage. So for today's agenda, we'll talk about file storage for SaaS and analytic workloads. We'll talk about pain points, some solutions to those pain points. Then we'll talk through some real customer use cases, including one that Dave is going to talk to us about. And then Perry is going to deep dive into the topics that we discussed in order to provide you all with more information and context into some solutions that you can incorporate into the use cases that you have as customers. All right, so let's start by talking about SaaS and analytics applications and their storage needs. Shared file storage is often a requirement that comes with these applications, either because of the use case that you're trying to satisfy. In the analytics case, data scientists and researchers, they often consider file storage the language of choice for interactive access to common data sets. For SaaS use cases, file is often the best representative format for the type of data that your application needs or your customers used to interacting with. For both, however, a number of common properties emerge, right? Shared file systems allow for concurrent access on a shared data set. The file system layers helps you broker access to that data using protocols that offer locking capabilities and single writers and all those sorts of things. Another common property is the need for scale. Scale requirements vary all the time in both of these use cases based on customer behavior in the SaaS use case or the business need in an analytics use case. And you want storage that scales up and down with what your applications need. The system needs to be cost effective, right? It needs to have the ability to store a long tail of data at low cost, right? On timelines that can span years. And you want that data to be available in minutes at any point if you need it for your business use case. And the system needs to be resilient, both from an availability and durability perspective. You need to be able to build applications that meet your customer need. So let's talk about some use cases. Pardon me. All right. So let's talk about what customers mean in terms of what customers want. Right? Customers want systems that are simple to set up with as little configuration as possible. They want systems that are scalable, both by storage capacity and from a throughput point of view. They want systems that work within their application architectures. Their applications often have a mix of compute patterns, ranging all the way from like EC2 in a more classic deployment to containers or serverless. And you want storage that meets the needs across the board. And you want storage that is cost effective with as little money, with as little cost being spent on underutilized resources. All right, so let's bring in EFS. EFS is the file system that was built from the ground up to be bottomless and just work in as simple a way as possible. All right, so let's recap on our original topic of SaaS and analytics applications. There's a wide variety of use cases where customers are deploying SaaS and analytics applications. Some of them include data science, right? Genomics, machine learning, billing applications for telcos, things like that. You have modern apps that are built using containers and serverless using shared storage. You have SaaS applications, either serving DevOps, content management, media capture, transcoding. And lastly, you have things like financial simulations using applications like Murex or KDB, where customers want to build an environment where they can backtest algorithms across like large historical data sets. So let's go through and talk about some use cases. One of the first that we're going to talk about here is one of our very own, Amazon Code Whisperer. For anyone who doesn't know, Amazon Code Whisperer is an AI coding companion. Code Whisperer needed shared storage in order to provide their researchers and engineers an environment to test machine learning algorithms and generate code in real time. And they use EFS, which is a really interesting, generative AI use case using EFS. Here's a quote from Srini, Code Whisperer's head of engineering, that highlights some of the benefits that interactive access to common data sets provide for the Amazon Code Whisperer service team. Next up is a use case from Kensho. Kensho is the AI innovation hub of S&P Global. Kensho built a ML audio analytics solution using EFS as file storage and EKS for compute. Here's another quote from Kensho's head of engineering highlighting the benefits of EFS's elastic performance. All right, next up, I'd like to invite Dave up on stage to talk to us about his use case. So Dave, welcome.
Thank you.
Thanks for joining us today. Can you tell us a little bit about yourself and what you do at SAP?
Sure. So I'm lead architect for the SAP Enterprise Cloud Services business. Just as a bit of background, SAP is a large multinational software corporation. Our specialization is enterprise resource planning software, ERP. Our flagship product, S/4HANA, integrates various business functions such as sales, supply chain, human resources into a single system. Gives our customers the possibility to have a unified view on their data and processes. The line of business that I work for, Enterprise Cloud Services, we accelerate our customers' transformation by moving their ERP systems into the AWS cloud for improved availability, security, and scalability.
All right. Yeah, no worries. Dave, can you tell us a little bit about the SAP and AWS relationship and how it's evolved over time?
Sure. Yeah. Can you hear me? Okay, good. Sorry. So yes, we've been working together for over 15 years now, innovating on many offerings for our customers. Most significantly, I would say, in 2016, we released the first dedicated infrastructure for HANA, large in-memory databases. And in 2019, this was expanded further, offering instance sizes all the way up to 24 terabytes of RAM in a single system. So running some very large databases. Today, the majority of SAP services are available on the AWS cloud, such as S/4HANA Private Cloud Edition, SAP NS2 Secure Cloud, Business Technology Platform, and a number of other services such as Concur, Signavio, Qualtrics. We work together for the Rise with SAP to transform our customers and critical systems to the AWS cloud.
All right. So Dave, can you talk to us next about, maybe like your use case more specifically, how you use EFS, and then, what are some of like the challenges that it helps solve in your use case?
Yeah, sure. So here we have an example of it's highly simplified of a S/4HANA deployment. They range dramatically in size, depending on the customers, from just some servers to hundreds of servers, hundreds of terabytes of both RAM and storage. The deployed stack is a typical 3-tier deployment with a presentation and an application tier, followed by a database tier. As shown here, at the heart of that deployment is the EFS file system. The application and web tiers have a lot to do with that, and that's the reason for it being present.
All right, great. So like if you didn't have something like EFS in the middle here, What would this look like, and how would it be different?
Yeah, sure. So we can obviously create our own technology for handling that. These things can be done. They are not necessarily particularly easy, especially if you talk about the robustness required for our customers. Customers run their entire SAP and their entire business on our platforms. Therefore, the system needs to be incredibly reliable and robust.
Great. So maybe we can go a little bit deeper here into like some of the things that you use it for. So can you walk us through some of those?
Sure. So EFS file systems in the context of SAP, typically we have shared binaries, kernels, configuration data from a kind of system point of view. From a more customer-facing point of view, they transport data, interfaces, and custom application data, which they're responsible for. And I think it's worth pointing out that what we talk about here is application infrastructure. Customers themselves develop applications, data producers and data consumers on top of that service, and therefore that's what's used for the EFS file system.
Cool. So what are some of the benefits or some of the features of EFS that you utilize that are core to making it the right solution for your architecture?
Yeah, absolutely. So calling out a few here, focused on 4 key areas: scalability, reliability, performance, and cost efficiency. So touching on those a bit, scalable because our customers come in all shapes and sizes, as I mentioned before, and they also may grow significantly whilst they're with us. This also happens. Reliability, our customers literally run their entire businesses on SAP, so the underlying infrastructure to support that has got to be good. Performant, yeah, many customers have spiky demands in their processes, month ends, year ends, busy retail periods, this all happens. And cost efficiency, at the end, who doesn't like cost efficiency? Basically, the technology to support the service should provide technology to optimize that cost wherever possible.
Great. So maybe you can talk to us about the scale of your deployment.
Yeah, sure. So we have fairly significant deployment, I would say. We have deployments present in every single AWS region, -1, I think, plus both AWS China regions. We have thousands of EFS file systems today, a number which actually rises on a daily basis. And we have approximately 2 petabytes today, but again, that rises daily. 2 interesting statistics here. We have about 80% now of our EFS file systems using elastic throughput, and we see approximately 50% benefit of using infrequent access.
Yeah, so we'll talk about those features in more detail in a little bit, but that's pretty interesting that you're able to derive so much benefit from that. So elastic throughput, right? What that allows you to do is to remove throughput provisioning from file system configuration, and your file system is able to scale based on usage, either up or down, and you pay as you go. It's like, what sorts of benefits did you see switching to that? And that, by the way, is something that we launched last year at reInvent.
Yeah, I mean, well, we started with a practical example. Here we have an example of a quieter file system. Before, this was on a static provisioned throughput. This was switched to an elastic throughput policy. And just to reiterate, an elastic throughput policy delivers highly scalable performance in exchange for a charge for read-write gigabytes. This delivers massively increased performance, actually, in our case, with a reduced price, which is doubly good. Crucially, the metrics needed to make an informed decision about that throughput settings can be derived from the usage of CloudWatch metrics.
All right, so next, let's go a little deeper into infrequent access.
Sure. Again, another practical example. These really are genuine. We have an example here with a larger file system with a fairly significant amount of cold data within it. This time through usage of an infrequent access policy, This transparently archives cold data to a significantly cheaper tier. When access to data is then moved back into the standard tier automatically. Crucially, this means that the warm and cold data can coexist in the same file system, and storage cost benefits can be derived automatically. So one thing I do want to call out is the spike. So this happens during the initial archiving of the data, but ultimately you can hopefully see here that the run rate is so much lower that it's almost immediately recognized.
Right, so what you're seeing here is the transfer cost of a significant amount of data getting moved from our standard SSD tier to our infrequent access tier, right? Which is like effectively a one-time penalty that you'd be.
It's a one-time penalty, and as you can see, it's paid back in a couple of days.
Right. So similar to this, we launched an archive storage class on Sunday, which allows you to store even colder data at a sub-cent rate per gigabyte. How do you see that fitting into your use case and into your architecture?
Yeah, we're very excited about the feature. We're going to be trialing that very soon. Basically, I'm convinced that this will deliver improved TCO for both us and our customers.
Right, I'd hope to see next year. We'd show this graph with another step down. I think would be the best thing that could come out of this feature, basically. All right, so what's next for your customers? What are you excited about? Tell us more.
Yeah, sure. There was also announced during reInvent the increased performance. So this will basically allow us to position new services with EFS, which require high-performance NFS file systems. Customers have a clear appetite for increasing amounts of data, and it's good to see underlying storage systems improve in performance to accommodate that. In more general terms, looking back over the week, we also, and a nod to that increasing usage of data, we basically use those high memory instances, as I mentioned before, to power our Rise with SAP offering. The next generation of high memory instances was already released, it's released as a preview, with sizes all the way up to 32 terabytes of RAM. So this will drive ever more increasing amounts of data, and with it, for sure, on EFS as well.
All right, great. Dave, thanks again for joining us on stage here today. We really appreciate it. Next, I'll pass it on to Perry, who is going to provide us a deeper dive into some of the topics that we discussed. So Perry. Go.
All right. Thank you, guys. Alex, thank you for kind of setting the stage for what I'm going to talk about. And again, Dave, thank you for joining us. It was fantastic to hear exactly what SAP is doing. So as Alex said, I'm going to do a little bit of a deep dive into each one of these areas to make sure that we're kind of giving you the lay of the land from an Amazon EFS perspective. So before I jump in, my name is Perry Jeanette. I'm a solution architect for storage, specifically aligned with EFS. Personally, when I come to a session like this, I want to get 3 questions answered. Number 1, what is it? What are we talking about? Number 2, why is it relevant? And number 3, how are customers using it? So Alex addressed the first one when he was describing Amazon EFS, and then walked through a few use cases, and more specifically with Dave and SAP, addressed how customers are using it. So I'd like to provide you some context in these 4 areas, and specifically related to the technology and how that is significant or relevant for data analytics and SaaS. So let's talk first about what does configuration-free file storage mean. When you create an Amazon EFS file system, you can create it with literally just the push of a button. And if you want to get as fancy as giving it a name, you can absolutely do that. By the way, we recommend that you do that. But configuration-free file storage means that Amazon EFS is really a complete managed service. So you don't have to think about things like patching, upgrades, failures of hardware, right? you're focused on running your applications, optimizing your applications for your customers. The other thing you really don't have to think about from an operational perspective is forecasting cost, forecasting storage, forecasting performance, right? That is all taken care of within the service itself. Amazon EFS is also highly available. The way it's architected is it writes data multiple times across 3 AZs. So the SLA that we'll give you on Amazon EFS is 4 nines, 99.99%. And when you think about that, it's really making sure that your data is, number one, highly available, but also highly durable, which we'll talk about next. The second piece about being highly available is really integrating with the rest of your architecture, your application architecture, and making sure that your architecture can be highly available as well. I mentioned that we write data across 3 AZs. So as you look at your application architecture, you can put those across those same AZs. Number one, you have that redundancy and that high availability. But number two, and probably just as important, you can make sure that you are optimizing your performance by having multiple clients, multiple threads within each client, multiple directories, multiple file systems. The more parallelism you give to Amazon EFS, the better it performs. Hence, the better your application will perform. On data durability, we offer 11 nines of data durability, and we achieve that. Number one, I just said we write across 3 different AZs multiple times, write your data across those 3 AZs. But even within an AZ, we're writing that data multiple times across physical hardware that is also redundant. Think redundant power, redundant network, redundant everything within the physical devices themselves. Beyond that, we're doing integrity checks as well as durability auditing to make sure that your data is stored properly and is safe. The nice part about this data durability is if a single component fails, like a physical device or even an AZ, you're still safe, right? Again, we're writing this multiple times across multiple AZs, providing that data durability that you would expect. And I'm not sure if you're aware of this, but in every presentation you're going to see at reInvent, there's going to be a security slide. So here's my regulated security slide. I'm kidding. But the thing with security is, we talk about Amazon EFS being incredibly simple to use, and it absolutely is. But it is also incredibly sophisticated. And one of those areas where we take sophistication very seriously is around security. And again, I'm not going to go into every vector of security for Amazon EFS, but I thought I'd pull out 3 different areas. The first is, as you load data onto Amazon EFS, or as your application generates data and stored on Amazon EFS, we want to make sure that we're encrypting that data in transit and encrypting that data at rest. The second piece is really using IAM as part of your overall security profile to make sure that you're setting a policy for your users, your groups of users, or your applications to make sure that the right people can do the right tasks with EFS. An example of that is setting users from an IAM perspective who can actually create or delete file systems within an IAM policy. The third thing I would say about security is Amazon EFS has a technology we call access points. And it's really an application gateway, if you will, from the application into the storage. And the nice part about this is you can actually limit what applications see, what users see. Number one, Amazon EFS is POSIX compliant. And number two, when you create these access points, you can create them and specify the root directory. So a simplistic example is you have multiple applications running on an EC2 instance connecting to the same EFS storage, I can create an access point for each one of those applications, and that application can only see what's in its root directory. It cannot see anything else on the Amazon EFS file system, right? So making sure that we're doing that segregation as well. So as you think about this entire section that we're talking about right now, from a SaaS perspective, when customers entrust you with their data, you have to make sure that, number one, it's always available, highly available. Number two, it's durable. And number three, it's secured on the platform. So in the case of SAP, making sure that the customers are confident that they have that kind of resilience, and I'm sure in your contracts, they have those SLAs specified. From a SaaS perspective, it's from a data analytics perspective, it's very similar, meaning whether the analytics or analysts are talking to you about this, they really want their data highly available, durable, as well as secure. So Amazon EFS helps with those things and helps at scale. All right, the next thing is fully elastic with no provision. So Amazon EFS is fully elastic and no provisioning. So again, what does that mean? Like Alex stated before, and Dave talked about as well, last year at reInvent, we introduced a new technology called elastic throughput, and that is one of our performance modes that you can enable. And right now it is our default. And since last year, we're seeing incredible adoption of this for reasons like Dave talked about, right? Number one, improved performance, but number two, you're only paying for what you're using. So elastic throughput has been really fantastic for our customers, both from a data analytics perspective as well as a SaaS provider perspective. And speaking of a performance, last year at reInvent, we introduced 2x lower latencies. So we have right now, from a reads perspective, 250 microsecond reads as low as 250 microseconds reads, and 1.6 millisecond writes. The second thing we introduced earlier this year is a 3x performance improvement. We are now, Amazon EFS now will give you 10 gig reads and 3 gig writes. And last but not least, from an IOPS perspective, we actually just announced this on Sunday. We now have 50,000 write IOPS, which is 2x what we had released earlier this year, and 250,000 read IOPS for frequently accessed data. So again, when we think about making scalable systems, scalable architectures, we think about making it simple. Our goal is really to make sure that we're increasing the performance so your applications, number one, can take advantage of that, but number two, are not hitting those roadblocks. So to wrap this section up, what is the value of having that fully elastic storage and fully elastic performance? Well, number one, we've decoupled storage from performance. And if you know anything about storage in general, the more data you put on, the better your IOPS become. We've decoupled that. And now we charge you for the amount of storage that you use and the type of performance that you'd like to use with that. So when you think about it from a data analytics perspective, right, one of the most expensive parts of doing data analytics is the compute. So if we can come up with file storage that is incredibly performant, then hopefully you can spend less on compute because your jobs are executing faster. And from a SaaS perspective, all of these benefits get passed right on to your customer. So both the performance benefits as well as the pay-as-you-go model. Now, let's talk about accessible from anywhere. And by the way, this is my favorite topic to talk about with Amazon EFS, and Alex mentioned some of this before. But Amazon EFS, think about it as persistent storage for a lot of the compute platforms that we have, compute services on AWS. Starting on the bottom right-hand side, we have Amazon EC2. And when you think about that, right, you are in charge and you own the operations of that, right? When you build Amazon EC2 instances, You're in charge of patching, upgrading, making sure it's secure, really handling all the operational functions. And then at the top left, Amazon Lambda, right? Really all you're responsible for there is writing the code, and AWS does the rest. So why is this important? Why is this relevant? I mentioned highly available architectures before. And as what we're seeing is a lot of customers are moving more from monolithic architectures to microservices. So they're moving more from, Amazon EC2 instances to things like EKS, or all the way to Lambda. The nice part is, when you're using Amazon EFS, the back-end persistent storage stays the same. So if you think about it, if you're moving from Amazon EC2, a monolithic application, to EKS with microservices, I can move those microservices whenever I want to EKS, and the back-end remains the same, meaning I'm getting the same kind of performance, and I'm accessing the same data. So it's fantastic. So why is this relevant to both analytics and SaaS? Well, one thing is common. One thing is constant in IT, and that is change, right? So as applications continue to evolve, we can continue to evolve our compute, and your back-end storage stays the same. It makes it seamless as you continue to evolve your application architecture. Excuse me for 1 second. And the last piece is cost optimize without any effort. Alex talked a little bit about the different storage classes that we have, and Dave actually talked about how they're using it and the cost savings that they're seeing. For me, when we think about total cost of ownership, the storage classes are a big part of that, but there are other things to think about. Amazon EFS has no commitments, no upfront fees, so when you provision a file system, it's empty, and you can start to fill it up, right? So in that equation, you pay for storage, and you pay for performance. So now you can balance your cost/performance equation to make sure that you're meeting your needs both financially as well as technically. The second is performance optimize. We just talked about elastic throughput and making sure that, again, your applications are getting and your users are getting the performance that they need, and they're getting the cost structure that they want. Again, pay as you go. And then the other thing is really optimized for compute. I mentioned this before, but really the biggest driver of cost from an analytics perspective is not storage, it's compute. So if we can continue to optimize the type of compute that you use, maybe it's spot instances, maybe it is serverless, then hopefully we can become cost balanced from a compute perspective. And again, keeping all of that data on the same back-end Amazon EFS. Well, one of the biggest differentiators for Amazon EFS is the fact that for each one of these different storage classes, and again, we have 3 of them, EFS Standard, EFS Infrequent Access, and EFS Archive, is the fact that the file name or the way you access the data remains the same. So your access, your user access, your application access is seamless, no matter which storage class you're on. Now, when we think about these storage classes, EFS Standard is the most performant, right? We're talking about sub-millisecond access, and this is really for your warm data, your hot data, your frequently accessed data, if you will. The second tier is infrequent access, and this is 94% cheaper than EFS Standard. So EFS Standard is 30 cents per gig per month. IA is 1.6 cents per gig per month, right? So 94% cheaper. The infrequent access class is really for just that, right? I'm going to access some data a couple times a quarter. And then the last is EFS Archive. We released this on Sunday. That is 50% cheaper than infrequent access tier. So this is really for long-lived, rarely accessed data. And Alex mentioned this before, but what we're seeing is, number one, from an analytics perspective, the amount of data is growing rapidly. But number two, the amount of data that people want to retain and access is also growing. So kind of that long tail continues to grow. The nice part is within Amazon EFS, we have something called intelligent tiering or lifecycle management. And really think about this as a schedule. So you have a lot of data in your EFS standard tier, you're actively using that, and as that becomes colder, we can set up a schedule to move this to infrequent access tier or the archive tier. So an example of that is, from an analytics perspective, we have a lot of data that we're using actively in a data set that we're looking at. And I think people probably all get how analytics, kind of the typical pattern around analytics, meaning, number one, we're going to load data onto our storage platform. Number two, we're probably going to do some ETL, some transforming of that data. And then we're actually going to run our analytics. All three of those processes are storage intensive, and for the most part, compute intensive. But after that analysis is completed, number one, hopefully we can remove a lot of the compute from the architecture. And number two, when we look at storing that data long term, if we have our tiering set up on a schedule, that data, as it becomes colder, moves to the inactive tier, and then ultimately the archive tier. Like I said before, the way you access the file doesn't change, or the way you access the data doesn't change. So in this example, let's say 6 months later, the analytics team wants to rerun the analysis with some new data, but they want to also use the old data. They would access those files the exact same way, and we, on the back, behind the scenes, would actually move that data from the archive tier back to the active tier, or the most performant tier, so you could run that analysis. After you're completed, it goes through the same cycle, and your data can be stored on the cheapest storage tier. So now, what is the kind of compelling reason, or why is this relevant? Well, from a SaaS perspective, all of this is cost following, meaning you can present this back to your customers, whether it's the performance or the cost optimization, and make sure that you're relevant and you stay relevant as they look to renew their contract, right? Nobody's looking to pay for more in the future. They're looking to pay the same or less. And then from an analytics perspective, as we, again, the amount of data continues to grow, we're looking for cost optimization to make sure that we're having that data available and relevant for our analytics teams so they can continue to do their job and execute those analytics. Oops, pressing the wrong button. Okay, so as we wrap this session up, number one, I hope I did what I said I was going to do, and that was talk about the technology and tell you why it's relevant for both SaaS and analytics workloads. And number two, really the thing that we're trying to drive home here is, from an analytics perspective, we're trying to provide a storage platform that can deliver insights faster. And we're trying to, from a SaaS perspective, we're trying to drive faster time to value. So you're meeting your customers' needs now and in the future. And the way we're doing that is we're continuing to make our platform our service simple. And we're trying to make sure that we have the agility that you need within your application architectures to make sure you're continuing to evolve your applications. By maximizing your value from your resources, like your compute resources, and making it easy to consume. That is it. I want to thank you for your time, for attending the session. I know there's a lot of different options you could use, or a lot of different sessions you could attend, but we want to thank you for taking the time to join us today. As always, there's plenty of learning resources on aws.training. This is specific to storage, but it's really available for any one of the AWS services. And then I'd like to thank you one last time and remind you to please complete the survey. We are a data-driven company, and we take that data seriously, and we try to improve our sessions year over year. So thank you, everybody. Appreciate it.